functions and all your classes and all your methods so that developers can really make use of the documentation that people write. So if one developer develops something and the other developer needs something, you can find it in the documentation and know what function to use. What I see a lot in companies that don't do a lot of documentation is that the wheel gets reinvented a lot of different times. For example, one developer needs something to sort an array in a certain way and writes a function. The other developer doesn't know about this function at all and has no way of looking it up and writes his own implementation of the same functionality. And having documentation that you can go through and that you can search is helps a lot in that respect. Another tool that we employ in a lot of our projects is a wiki. Many of you know Wikipedia and the software that Wikipedia runs. You can basically install it on your own server and run your own wiki. And the really interesting thing is that it's a really low threshold way of making documentation, because in a wiki you can just look at documentation, you see something that is wrong, you click edit, you change it, you save, and you have updated documentation. A lot of companies still use things like Word documents for documentation, and the thing with Word documents is that it's a nice format to read the documentation, but they get outdated a lot. You have different versions lying around, nobody knows what the latest version is anymore, and wikis, online documentation, really help with that because you always have up-to-date documentation. An interesting thing is that you can even grant your customers access to such a wiki, and then even your customers can read your documentation and can help improve the documentation. That can save you time. Next thing to look at, before we start actually coding the application, is to look at the foundation. If you just start stacking bricks, if you just start writing code, from scratch, it might not be that stable, and you don't know how much it takes. You need a lot of bricks to build a skyscraper. So what you usually do is you start with a foundation. You have a kind of framework that you use, and then you build your bricks around that. It's the same for development. If you write code from scratch, you lose a lot of time reinventing wheels that somebody else has already invented. If you use a framework, you can reuse code that other people have built. Frameworks also provide off-the-shelf components. For example, you don't have to write your own database access layer. You don't have to write your own caching. You don't have to write a lot of things, for example, things like logging, etc., that the framework already has. So you can save a lot of time by using frameworks. And these are just a few examples of frameworks. There are really literally hundreds of frameworks out there. There's always a framework that fits your project. These are just examples for several different languages of frameworks that are out there. One interesting thing when looking at frameworks is that a lot of developers have what is called the not invented here syndrome. Basically, that means they look at all these frameworks and say, I can do this better, and they write their own framework. Or they see a framework and they say, hey, I need this framework basically has this set of features, but I need this feature here, so let's write my own framework. Or they say, hey, the framework provides all of this big functionality, but I just need this, let's write my own framework. But the thing is, the problem with writing your own framework is that it's not only time-consuming during development, it's a lot of time-consuming during the actual maintenance phase. Because if you write your own framework, you have to maintain it as well. And even if you have something like, hey, I'm not using this framework because I only need this, and a couple of years down the line, you have added functionality, and you've added functionality, and you have written your own framework that is like this. In the end, you've added all the features that you didn't want in the first place. So it's really important to look at existing frameworks, because it will cost you a lot of time if you develop your own framework. One thing, for example, is if you have a framework that has an active community, they will help with finding security issues, and they will help with fixing bugs, and that's all things that you don't have to do yourself. And while you're writing the framework, that's all good fun, and it's all you're spending a lot of time on the framework, but it's all fun, and you're getting there. But 1 year later, when you're maintaining it, you're no longer interested about developing that framework, but you still have to maintain it. So really useful to just look at existing frameworks and try to adapt them. Most frameworks are really adaptable. If they provide these features, but not this extra feature that you need, you can basically add that to that framework and even contribute it back to the framework project, so that others can maintain it for you and others can extend on the feature. So it's really a useful way of to look at the existing frameworks and do something with that. Another interesting thing to look at is design patterns. Here's a requirement that's typical for a building. You need to be able to look outside, but we can't make a hole in the wall because it rains all the time in Poland and in the rest of Europe. So we need a solution to deal with this requirement. Now you can't go to a shop and say, hey, I want a window, and then you have a window and that's it. Basically a window is a concept, it's not a product. You know, there are a lot of different projects that implement this concept. There are a lot of different windows out there. It's like a best practice way to solve a particular problem. We have similar things in IT, and there we call it the design pattern. So a design pattern is basically a best practice way of solving a problem. A lot of problems you encounter when developing a web applications are already thought out maybe differently by others. You know, a lot of problems have common solutions that you can implement. And those are basically collected into a set of design patterns that basically describe, hey, if you encounter a problem like this, then this is the way you can solve that. So you don't have to think about the design for your solution yourself, because you can use a standard design pattern. Now, the MVC that we already looked at is an example of such a design pattern. You know, it's a best practice way of solving the separation between logic and layout. But there are others as well. A factory pattern is a pattern to create objects. A singleton is something where you can say, hey, I only want one instance at a time of this object. I don't want multiple database connections, so I have to make sure that this class is never instantiated twice. Well, there's a solution for that, and that's called a singleton. And basically, there's a description that says how to implement such a singleton. There are a lot of examples here. Again, Wikipedia is a nice way of starting, because if you look up design pattern at Wikipedia, there's a big list of patterns with a good description about them. And if you do PHP development, which a lot of you do here, then I recommend this book, because that basically describes how to implement certain patterns in PHP. And not only that, it also describes which patterns are useful in PHP and which aren't as useful. There are a lot of books on design patterns out there, and if you have never heard of a design pattern, it's really worth studying, because you can again save a lot of time by implementing standard best practice solutions for certain problems. Another important factor when doing enterprise development with scripting languages is to look at testing. A common feature is that, you know, software is tested after it has gone live. And the reason why that happens is that, you know, in the classic development model, you do your testing at the end of the project. Now, some things go wrong, so your deadline is looming and you still need to fix features. So the first thing that gets dropped when your deadline is near is testing, because that's at the end of the project. So what often happens is you just create a project, you don't have time for testing, and you just ship it, and then your customer finds the problems. That's not really a good way to ensure quality. So it's really important to look at, you know, at testing as an important aspect of a project. And there are several ways to do testing. For example, one of the most basic ways to test software is developer testing. You write your code and you test your code. You know, the developer tests his own code. But it's also important to look at functional testing, because even if you develop flawless code, that doesn't mean that it adheres to the functionality that the customer needs. So you always have to do functional testing. And this is something that your customer can help with, because the customer can test against your requirements. He can test if the software not only works, but also works according to his expectations. With web applications, we also have to do environment testing. We need to make sure that our application, you know, works in Internet Explorer, it needs to work in Firefox, Google Chrome, whatever. It needs to run on Windows, it needs to run on Linux. You have all kinds of different environments. And if you foresee that your application is going to run on these different environments, that's something that you'll have to test. Because nothing is more frustrating than, you know, developing it on Linux, delivering it to your customer, and everything breaks because they are running on Windows. So you have to do environment testing. Also important is to do performance testing. If performance is a requirement, you know, if you have a high traffic website, if you build a website that's in the top 10 of websites, then performance is important. And it's frustrating if you build something that works perfectly, it fits the requirements, but as soon as you go live, everything, you know, just breaks down because it can't handle the 10 visitors that you start with. Now that's important to do actual performance testing. There are a lot of tools out there, and if you Google for performance testing for web applications, you'll find a lot of tools that can help you with these performance tests. A final one that's interesting is usability testing. Even if the feature meets the requirements of the customer, you still have to look at the usability. And usability basically means, is the user able to effectively use your feature? For example, if publishing articles is his core business, then that shouldn't take half an hour to publish an article. It shouldn't take hundreds of clicks to publish an article. The usability is really, you know, making sure that a feature is as easy to use as possible. You know, in few clicks, with a good screen, not a lot of scrolling. And it's really useful to do that with your customers as well. Most customers have what they call key users, you know, that are the most important users that are going to use the system. And usability testing can, for example, already be done by just having such a user use the system and just monitoring him. Watch what he's doing, how he's using the system, if everything is intuitive, if he can find the features. So that's a nice thing to look at. if we look at testing, and we are fixing bugs because we are testing something and we're fixing a bug, then a common scenario is this. You have built an entire